Okay, in this third video of 3, we are going to analyze a linear word problem that is presented to us as a table. Okay, remember, we've already done one where we had our scenario and then the information was presented to us in the form of an equation, and we did a problem with a table of values. So now we're going to do one as a table. So what I'm going to do right now is leave this front page up for just a few seconds for you to either pause and copy down these 5 questions or screenshot it. These 5 analyzing questions are common, they're foundational, and you can ask them, and you will ask them for every type of function family that you're going to study in your high school and college math classes. So we may as well start learning these questions now. So let's go to our problem. Okay, here's our problem. So let's begin by checking it out. Cal State East Bay offers Bay accounts that allow parents or others to deposit funds for students to spend money. Maddie's parents deposited money in her account in January. Maddie uses this money to buy meals. Please answer the 5 questions based on the function below. In this case, the representation of this scenario is a graph. So let's talk about how would we label our X and Y axes. So we're talking about money and we're talking about buying meals, all right? So let's take a look at this function and think about it for a minute. So if they deposited money and then you're going to spend the money, then it would make sense that your y-axis being dependent, because how much money you have is dependent on how many meals you buy, right? If you don't eat, you're not going to spend very much of your money. So the x-axis is meals. It's the independent variable, and the dependent variable is the amount of money in your account. Next. So now let's look at the y-intercept. Here it is. It's up here at 500. So what does it mean in this particular circumstance? Well, what it means to me is that that's the amount of money that got deposited. So that's the amount of money that she started with. So the significance of it is her starting amount of money. Okay, her initial amount. So let's talk about the x-intercept. Will this graph have an x-intercept? Sure looks like it will, right down here at the edge of the graph. And what do you think that x-intercept means? Well, it means 2 things. It tells you 2 pieces of information. It tells you x-intercept it indicates that Maddie is out of money. Her account is at 0. It's at $0, and it also tells you how many meals she bought, right? there's that. So there's the answer to that question. Next, well, what's the slope of this function? Well, how do you find the slope when you're looking at a line? Well, first, you look at your axes and you figure out how to skip count everything. So this is 25, 50, 75, 100, 125. So each one of these tick marks is 25. And these go 5, 10, 15, 20, 25. So each one of these is 5. So you can pick a couple of points. You have a couple of things that you can do. You can pick a couple of points. So we've got 0, 500, right? And you've also got 5, 475. Right? So let's go ahead and do our x1, x2, y2, y1 thing. So let's have 500 minus 475, and that's going to be divided by, remember, we started with 500, so we have to start with the 0, 0 minus 5. So 500 minus 475 is 25. 25 divided by -5 equals -5. So the slope is -5. And that makes sense, right? It's obvious that this is a decreasing function. And even if you look at the word problem itself, or words that clue you in to that this is the correct way to look at this, right? You spend money, you're taking money out of your account. So it just makes sense. So this -5 stands for what? It's dollars, because this is dollars, right? It's dollars per meal, right? So the slope, the rate of change, just going to make it ROC, your slope or rate of change is -5, and the significance of that is dollars per meal. Okay? And once again, it's obvious this is a decreasing function. So now I'm going to pause for a minute so we can erase this and then answer our last question, which is what is the domain and the range of this function? When we talk about the domain and the range, remember that the domain is the set of all possible x's. And I'm really happy that we're working with a decreasing function, because when we get to the range, it's going to inform you of something that's pretty cool and pretty important. But right now, let's look at all the x's. So like many practical application problems, your x begins with 0, unless you are allowed to have negative values for whatever your x-axis measures, which is not normal for most situations. Since you're talking about your x-axis being meals, then you're only going to deal with positive meals. You can buy 0 meals. So we're going to have a bracket and the number 0. Well, you also have an endpoint. This function doesn't go on forever. They're telling you how much money that you have, and they're telling you how much each meal is. So there is a limit to the number of meals you can buy, and that number is 100. And because you can actually buy 100 meals, you have to close your interval with another bracket. Okay, so now let's look at the range. The set of all possible y's. Now remember that even though the graph gets read from left to right, you always begin an interval with the smallest value first. So even though the 0 for the y is all the way over here, you're still going to begin with 0. Okay? And then what is the highest? Well, that's your initial value, right? 500. And once again, you had $500, so you have to enclose it in a bracket. So now let's translate these into inequality notation. So because we have endpoints here, it doesn't go on forever, we're going to have our x in the middle of the two endpoints. And because this is a bracket, it's going to be 0 is less than or equal to x. And then likewise, because this part is a bracket, we're going to have all your x's have to be less than or equal to 100. Well, let's do the same thing with the range. So we've got 0 again. All of our y's are going to fit in the middle of this range, right? So they can start at 0, be less than or equal to, and cannot be greater than 500. But because, once again, we have a bracket, we need to make sure that we have that equal to, because the value on the endpoint is included. That does it. Analyzing the key features, that's another fancy way to say this, analyzing linear word problems using our 5 basic questions. See you in the next video.